Well, welcome back everybody. We're going to continue building on what we established yesterday about algorithms and pseudocode, and today we're going to add another dimension to that. We're going to build some flowcharts. Now, you've all seen flowcharts before. I've got another kind of funny flowchart on the screen. I'll zoom in on that and you can pause it and see that if you want, or go to the website that I have listed there. But there's a little bit more order to a flowchart than you might think. The shapes that are chosen for each step in a flowchart actually represent a particular type of process. So we're going to establish that today. And we're also going to look at the decision structure of flowcharts. So let's get started. So let's start by looking at the three most basic shapes that are used in just about any flowchart. For starters, we have a terminal symbol. A terminal symbol is used to start or end a process or a flowchart. We're always going to need at least one of these at the beginning and one at the end of any flowchart that we make. And of course, we're typically going to be dealing with some kind of inputs and outputs, and so we use a parallelogram for inputs and outputs. And we'll be using a lot of calculation symbols. That's just a plain old rectangle, and that shows you that some assignment statement or some process has to happen, usually using our inputs. Now there are certainly more symbols than these, but these three will get us started. Okay, so let's look at our work from yesterday. We created an algorithm yesterday that determines the value of a piece of land given its length and width, and I have our algorithm shown on the screen. Let's create a flowchart to do this. Now for your work in the next lesson, we're going to use some software to do this, but for today, we're just going to freehand these, and for the work that you send to me, freehanding is just fine, but you certainly can use any piece of software if you'd like as well. So we know no matter what, we have to start our process, so let's do that. Now, our algorithm said that the next thing we should do is get our inputs, L, W, and P. Those were the length, the width, and the price per acre for our land. And we're going to use a parallelogram here since we are asking for an input. Now, the next step in our process was to find the area of the land in square feet. Our pseudocode tells us what our calculation is going to be. We just have to make a spot for it in our flowchart. Now, it's a process or a calculation, so we're just going to use a rectangle. And of course, that's going to flow into our next step in our algorithm, and that is to convert the area of the land from square feet into acres. And we said the subscript would distinguish the area in acres is equal to the area in square feet divided by 43,560. And of course we had one more calculation after that. Then we found the value of our piece of land V by taking the area in acres and multiplying it by the price per acre. Then our last step was to output those values. So we're going to have that lead to another parallelogram. And we'll output our area in acres and our value of our land. And finally, we'll lead to another termination symbol. Where we will stop our process. Now that's a pretty straightforward example. That really just takes the information that we already knew, assigns it the appropriate shape, and we're all set. Now, oftentimes you'll see arrows in a flowchart, and you can certainly put those in. Our start and stop sort of indicate the direction that we have to flow, but arrows really don't hurt, and so we'll include those here. Okay, let's do one more example and I'll give you one for practice. A self-serving parking meter charges $3 for the first hour and 50 cents for each hour after that. That's a pretty common pricing structure for a lot of cities that are switching to a digital way to pay for parking. Given that someone parks in the lot for more than an hour, so we're going to assume that they're there for more than an hour, let's determine the amount that they'll be charged given the total number of minutes that they're in the lot. Okay, so let's start by writing the pseudocode for this. We'd begin by needing to know the number of minutes. So we'll have an input of m, where m is the number of minutes that they're parked in that particular parking spot. Now, we come across a little problem here because we're charging by the hour, but we're given the number of minutes. So we need to convert this number of minutes into hours. So let's change M to H. Let's let H be the number of hours that were in the lot. So how do we change the number of minutes into the number of hours? Well, if we were in a lot for 60 minutes, that would be 1 hour. 120 minutes would be 2 hours. So we're going to take the number of minutes and divide it by 60. But there's a problem with that. For example, if we're in the lot for an hour and a half, that would be 90 minutes. And if we divide that by 60, we get a decimal number. Our pay structure doesn't work like that. It charges for 50 cents for each half hour after that. So we need to round this up and say that we're there for 2 hours. Now, in mathematics, there's a function that doesn't get used very often. They're called the floor and ceiling functions, and I've got a link on your screen. You can go to Wikipedia and do a search for floor and ceiling functions if you want to read more about this. But what a floor and ceiling function does, and I'm going to jump to another piece of paper here for a minute, is it rounds decimal numbers either up or down to an integer. The symbols for the floor function are kind of like a bracket but with no cap. The ceiling function is just the opposite. That's like a bracket but with no bottom on it. And floor and ceiling functions always round down or up to the nearest integer. So for an example, what I mean by this is if I asked you what the floor on the number 3.7 was, the output of that function is to take 3.7 and round down to the nearest integer. That would be 3. But if I asked you what the ceiling on 3.7 was, then we would take 3.7 and send it up to the nearest integer. The value of 3.7 would be 4. So this doesn't follow normal rounding rules like 0.5 and higher rounds up. It's strictly if it's anything above 3, we round down to 3, the nearest integer for the floor function. Anything above rounds up to the next integer for the ceiling function. If we apply these functions to an integer, it just stays the same. So for example, the floor function on the number 6 is 6. The ceiling function on the number 6 is also 6. Integers just remain unchanged. So to make sure you've got the concept on that, what would the floor function on 17.2 be? Well, hopefully you just recognize that if we round that down, the floor function on 17.2 is 17, whereas the ceiling function on 17.2 is 18. So how does that apply to our parking meter question? Well, the number of hours that we're going to be parked in a spot will be the number of minutes divided by 60, but that could very likely give us some part of an hour, some decimal part of an hour. And the meter is always going to charge us for the whole hour whether we use it or not. So we're going to introduce one more variable here, and we're going to call it t. And we'll let t be the time we're being charged for. And since they always round up, t is simply going to be the ceiling function on the value of h. So just to make sure you're with me here, if we parked in a lot for 435 minutes, that would be our m value. If we divide that by 60, that would be our h value. That would be 7¼ hours. But the time we get charged for would be the ceiling function on h. The ceiling function on 7.25, that would round up to 8, and that means that the meter's going to charge us for 8 hours. Now we'll let C be what the total charges are for this. Keep in mind that it's going to charge us $3 for the first hour, so no matter what, we're going to pay $3. And then we're going to get charged 50 cents for every hour after that. Now, if we park for 2 hours, we're not going to get charged 50 cents twice. We already paid for the first hour in our $3. So 50 cents shouldn't be charged by the amount of time we're being charged for. It should be the amount of time minus 1 hour, because the $3 pays for the first hour. So if we're parked for 2 hours, for example, we'll get charged $3 plus 50 cents for 2 minus 1. That's 1 more hour. And now that we know C, what our charges are for parking in the space, that can be our output value. And we're done. Now we can turn that into a flowchart. And there we are. We started our process. We got our input of M. We took that value of minutes divided by 60 to get the number of hours. The time charged is the ceiling function, or the number of hours rounded up to the nearest whole hour. Our charges are $3 plus 50 cents for every hour past the first one, t minus 1. And then we output our total charges, and then we stop our process. Okay, here's one I'd like you to try for practice. The pay structure for people who post on YouTube is pretty complicated, and you can follow the link that I have on the screen there if you're interested in reading the details, but it kind of simplifies to something like this. Most posters on YouTube get paid once their channel reaches somewhere in the neighborhood of 10,000 views, and your pay rate depends on lots of different things, but to oversimplify it a little bit, your pay rate might be somewhere in the neighborhood of about 12 cents per view of the advertisement in front of the video that you post. Now, the pay rate's actually a little bit higher, but Google keeps a chunk of that. The trouble is that most people don't watch the advertisements before a video, and only a small percentage actually do. So I'd like you to create a flowchart that determines how much a channel creator should get paid based on the number of views of their video, the percentage of those viewers who actually watch the advertisement before the video, and the pay rate per view. You can, for this example, assume that somebody has already exceeded the 10,000 view threshold to get paid. So that's a little bit tricky, but think about that and see if you can come up with that. We'll work through one solution when you unpause the video. Okay, well, let's take a look at this. The three inputs that we need to know and that we're basing our pay on is the number of views, we'll call that V. P is the percentage of people who actually watch the ads in front of the video. And R is the rate of pay somebody gets paid per ad watched. So of course we need our input of VP and R to be our first step. Now, we have to account for the fact that they only get paid after 10,000 views. And so the first thing we need to do is we're going to let N be the number of money-making views, and the number of money-making views is going to be the number of views minus the first 10,000 which were not money-making. You're watching this lesson on YouTube right now, and it's nowhere near 10,000 views, so I'm not going to get paid. Now that we have the number of money-making views, we have to keep in mind that not all those people are going to watch the ad. So the amount of pay we're actually going to get is the number of money-making views times the percentage of people who will actually watch the ad, because those are the ones who actually earn money for us, times whatever their pay rate is per video. So here again, we did this yesterday as well, but I'm using lowercase p for the number of ad watchers, and I'm using uppercase P for the total pay. Variables are always case sensitive, and so when you write variables, you should always distinguish between lowercase and uppercase. And that is the value that we're trying to find, and so we can output that value P, and we're done with our pseudocode. Now let's just test out this theory. Let's suppose we have 15,000 views, and let's assume that 5% of people watch ads, and that our rate of pay, as we said initially, is 12 cents per ad watched. So in our case, the 15,000, that's going to be our value of V, 5% is our value of P, and R is 12%. So if we compute N, the number of money-making views, that's going to be 15,000 minus the first 10,000 which were not money-making, and that leaves us with a number of actual money-making views of the 5,000 beyond those first 10,000 that don't really count for us. And then the amount of pay we're going to get is 5,000 views, but only 5% of those are going to watch the ads. Now we are going to assume that this is going to be in decimal form. You could divide that by 100 if you wanted to leave it in percentage form. That would be okay. So there's our 5%, and then we're going to multiply that by 12 cents per ad watched. So 5% of the 5,000 people I'm getting paid for watch the ad, and whatever that number turns out to be, we'll multiply that by 12 cents per ad watcher, and that's how much I'm going to get paid. And as it turns out, I'm going to earn $30 for the 15,000 people that watched my video. Now we can turn that into a flowchart. So when you're all done, we should have an oval that starts our process, a parallelogram that gets our inputs, a couple of rectangles that describe our process, another parallelogram for our output, and another oval to stop the process. If you have something like that, you should be in good shape. Okay, before we can do much more, we need to add another symbol. So we're going to add in the decision symbol. And a diamond represents a test of a logic statement or a decision that we can make before we decide what path to follow. We'll see that in action in just a minute. One tip of the diamond usually represents where our chart flows in, and the other tips represent the possible different outcomes or directions we can go. But when we have a split, we usually have to bring those processes back together at the end, and so a small circle is a connector symbol, and that brings different paths back together. So here's what that looks like. Let's take a real simple decision-making process. What are the two criteria that have to be met if you want to buy a Powerball ticket, right? You walk into a gas station that sells Powerball, and you want to buy a ticket. There's really two things that that have to be true for you if you want to walk out of there with a Powerball ticket. Now, the first one, of course, you need to be 18 years old, right? If you're not 18, you're not buying a Powerball ticket. But even if you're 18, that doesn't mean you can walk out of there with a Powerball ticket unless you have $2 to spend on the ticket. So if you're 18 and you have $2, then I'm sure that the clerk is going to help you buy your Powerball ticket and send you on your way. Now let's consider just the first criteria for a minute. Let's just look at the decision structure for checking whether or not you're 18 years old. Okay, so before we look at the pseudocode, let's just look at the flowchart. We would start our process and we would ask for input A for our age. And then the question we would ask is, okay, is this person less than 18 years old? In other words, are we dealing with a minor here? If that's true, see, we flowed into one corner of our diamond and then we've got a true branch coming out. If that's true, then the output from the clerk has to be, sorry, you can't buy a Powerball ticket. You're not old enough. But if that's not true, if they are not under 18, well, then they must be 18 or older. If they're not younger than 18, then the output is, yeah, you can buy your Powerball ticket. And again, we're not asking whether they have money in this example, but in either case, these two things flow back into a connector and get sent to the next step, which is to stop. Now the pseudocode for that would be pretty simple. Our first question would be, what is our input A? How old are we? If that person is under 18, well, then we have two possible outcomes. If they are under 18, then our output is, sorry, you can't buy a Powerball ticket. In other words, that would be our true criteria. Otherwise, if it's false or else, we say, you may buy your ticket. Now, let's adapt this chart slightly so that it takes into account both criteria for buying a ticket and not just one. So the first thing we'll need to do differently is we're going to have two inputs. Input A, that is to say, how old are you? What is your age? And also we're going to have an input C, how much cash do you have? After that, the first thing we'll do is check age. Are you less than 18 years old? Because if that's true, then our answer is you may not purchase a Powerball ticket, and it doesn't matter if you have cash or not. Whether you have $0 or $100, if you're under 18, you cannot buy a ticket. But what if it's False. And what if they're not under 18? Well, then we have to go to another decision, right? The next question we would ask if they're not under 18 is, how much cash do you have? Is your cash level less than $2? Now, what if that's true? What if the cash that they have on hand is less than $2? Well, if that's true, if their cash on hand is less than $2, then the output is, I'm sorry, you can't buy a Powerball ticket. You are old enough, but you don't have enough money. But if we ask them if they have less than $2 and they say no, that means they must have more than $2, or in other words, it's not true that they're short on change. Then our output is, yeah, you can purchase the Powerball ticket because they weren't under 18 and they didn't fall short on money. And of course, in either case, our process is done. So we're going to bring those two to a connector and stop our process. Okay, let's go back to this earlier example now about the pay that you would have from a YouTube channel. And let's reconsider this. Earlier we assumed that the number of views had exceeded 10,000. But let's adapt what we did earlier and take into account the fact that maybe the number of views hasn't exceeded 10,000. How is that going to change our flowchart? And then we'll write the pseudocode for this. Well, would we start out the same way? Would we have inputs of the number of views, the percentage of people that watch ads, and would we need to know our pay rate? Yeah, that's still going to be true, but what's the first thing that we would need to ask? Instead of automatically going on and figuring out the number of money-making views, we're going to have a decision point in here. So instead of automatically moving on to that next step, let's put in a decision point. And what does this depend on? Well, it depends on the number of views. We don't know that we're over 10,000, and remember, if you're not over 10,000, you get nothing. So the question we would ask is the number of views less than 10,000? That is to say, are you just getting started on YouTube? Now, what if that's true? What if we input the number of views, the percentage, and the pay rate, but the number of views is under 10,000? Well, then our pay value is 0, right? We're not going to get paid. And so we can automatically flow into a rectangle here where we're going to assign a value. That's an assignment statement. We're going to build on those in an upcoming lesson. But we can right there conclude that the pay value is going to be 0. And once we know that the pay is 0, we can automatically go down, output that, and stop our process. But what if the number of views is not less than 10,000? That is to say it's 10,000 or more. Well, then that's exactly the case that we had before. So if we're not under 10,000, if that's not true at all, then we can proceed with the flowchart as we had it. So slipping that one decision point in here will separate out the amateur YouTubers from those who are well established. Now let's write the pseudocode for that. Of course, we would start out by asking the same thing. We would need to know our inputs VP and R. And then we're going to have a decision point. Our first decision here is to check whether our views is less than 10,000. If our number of views is less than 10,000, then we can automatically assign a pay value of 0. But if it's not, as our flowchart showed, then we can proceed and assign a value to n, the number of money-making views. And the number of money-making views was the number of total views minus the first 10,000, which don't earn anything at all. Then what do we do with that? Well, as we showed on our flowchart, then we can figure out what our pay value is by multiplying those money-making views times the percent that actually watch the ads times our pay rate. And at that point, we've either got a p-value of 0 or a p-value that was calculated because we exceeded 10,000. So we can output our p-value. And again, that's capital P, that's our pay. and we're done. We've written the pseudocode that corresponds to our flowchart. Okay, again, if you want to do a little bit more reading about the pay structure for YouTube, I skipped over some details to make it a manageable problem. It's pretty complicated, but you can certainly Google that or go to the link that I have on the screen. Okay, well that wraps up this lesson. The real key points here, of course, are just being able to take the algorithms that we established and roll them into flowcharts. And so you need to know the symbols that we used. You need to know these five fundamental flowchart symbols. The terminal symbol, which is an oval, and that starts and stops a process. The input and output symbol, which is a parallelogram, and that's used any place we have an input or an output. And a plain old rectangle is our calculation or assignment statement value. That's where all of our computations are done. And additionally, you need to be able to use the decision symbol, which is a diamond. One corner is your input, the other ones are possible outputs. And anytime you have separate paths or a decision being made, you need to bring those back together using a connector. You should never have more than one stop symbol. We always bring those back together and lead to one ending point. So the assignment will be given in Blackboard. Go ahead and do that. Don't hesitate to reach out if I can help you out at all. And we'll continue this with a project involving kind of a complex flowchart in your next lesson. So we'll see you there.